Okay, so let's see IP address space. Okay, today. So this is something already. We have discussed about IPv4 address, which is 32-bit string, the 32-bit number, right? And let this tool enhance our understanding. So there are different, see, IP address is 32-bit number as it is explained here, which is 32-bit binary number. Since it has 32 bits, we can represent 2 power 32 numbers by arranging these bits in different combinations, right? So total how many numbers you can represent using 32 bits, a 32-bit string, binary string, you can represent around approximately 4.2 billion. So but this is total numbers, but IP address starts from, so what is this suffix I'm using? This is the number system. Do you understand? Yeah, so this is called radix or base. We to refer to denote the given number is in this in any number system. So we represent that using this base or radix of that number system. So this ranges from 0 to what is last one? This is this much, okay? Yeah, so which is a one less. Why? Because total, let's say, for example, if we take decimal number system, how many literals are there? Total 10 from 0 to 9. Yeah, including 0. Likewise, here total 4.2 billion, one less because including 0, we can represent till 4.2 429 4967295. Yeah, okay. This many IP addresses. So see, this is just we are representing. This is 32-bit number. So as we learned, if you take a 4 bits, 2 bits, what are different combinations? 00011011, right? Likewise, these bits can be arranged and to represent 4 billion numbers. So this too, let's scroll down. So from 0 to how many? 4 billion. Okay, let's take the some random IP. Okay, so if you take this random IP, what is this notation? This is decimal equivalent. See, I kind of actually, if I need to read this thing, I need to kind of need to pass a little, just couple of seconds to get what this whole big number is. Do you understand? So, but I can't. We can't communicate if I ask you what is your IP, you can say my local IP is 192.168.1.5. That is easy. But if I type 192.168.1.5, this is the decimal equivalent of that one. We can't communicate this way, right? But we can't. I can't. This is a very big number. Kind of actually, our brain hurts, mouth hurts. We need to pause for a while to get what is this. This is 3 billion, 22 million. Okay, that is very big. But this is quite helpful when it comes to hexadecimal. This is decimal, base 0, base 10. Hexadecimal is this is just a pure number that is represented in our decimal number system. Okay, so decimal number system here, this is hexadecimal number system base 16, and in some devices we can actually enter our IP address in hexadecimal number system this way. And in hexadecimal number system we can represent two ways. We can prefix 0x to represent the given let's say if we take this one, you can have hexadecimal number without A, B, C, D. Okay. Uh, Okay, so just a moment. Let me get some number which doesn't contain. Now tell me, if I don't include 0x, we don't know which is a it is a decimal or hexadecimal. Do you understand? So because in hexadecimal, a decimal contains how many literals? 0 to 9. In hexadecimal, 0 to f. So to distinguish that, we use 0x. Or if we don't use prefix of 0x, we can there are two ways. We can use small x or capital X. Okay. But if we don't use x, we must use a suffix to denote this is a hexadecimal. Okay. So this hexadecimal notation, and there is a dotted hexadecimal notation also that we use in some uh, on some devices when we configure routing and all. For suppose on a gateways, firewalls, or routers. Dotted hexadecimal is very simple as dotted decimal. We put a dot for a, okay. So that is dotted hexadecimal. Okay, but usually we don't use the dot in a hexadecimal. And this is binary. You tell me, let's take some random IP and how hard it is actually to communicate with this. Yeah. See, you need to look twice when you read because you're not reading the one twice or a zero twice. Do you get it? Yeah. So there are so many ones and zeros. Getting this number pronounced is itself is a difficult if you take a decimal, and you see how difficult it is to communicate with the binary notation, right? This is pure binary notation. These bits are arranged to make up 4 billion addresses. So we created a new base notation that is a easiest notation for us to communicate, which is a dotted decimal notation, which is base 256. Okay, so there are 256 literals from 0 to 256. Since it is hard to use symbols like it is hard to find symbols for 256 values, like we have a B, C, D, E, F in hexadecimal. We simply use 0 to 256. For suppose if we take let's take this one. Let's increase. Let me go decimal this one. If we increase, what is happening? Look at this. I'm changing. You can open this tool in your browser as well. Okay, you can go to Neo-util tools, networking, and IPv4 address. Okay, so I'm just changing. Look at this. What is happening? As I increase, this last octet is being changed. Okay, so it's very simple. It is, don't be confused. This is pure number we are representing as a dotted decimal. Do you get it? Last time you asked me a question. What is the IP address after 255? Okay, you see that is it will be pretty clear now. I reach 250. Let me. Okay, it is 180. Okay, instead of let me directly type 250. Okay. See, decimal 250 is a 0.0.0.250, which is FA, right? And in hexadecimal, you can put zeros, any number of zeros. Okay, in front. Okay, so here we not representing means you can assume. See, we have zeros, any number of zeros, but having zeros here doesn't change a value. Do you get it? Yeah, see in here also I can put any number of zeros, but that value won't change. But if I just put one, everything changes, right? Yeah. So likewise, since we have zeros here. Okay, so this is equivalent to 0000 FA. Okay, so now as I increase 255, this is last octet 254, 255. So what is after 255? Let's say 0 to 9. After 19, what you will get in decimal? 20. Yeah, after 9, what you will get in decimal? 10. Yeah, likewise in dotted decimal, you see after we reach 255, what is next IP? 10. Okay, so what is decimal? 256. Okay, see in hexadecimal, look at this. What is last IP? What is a 255 equivalent in hexadecimal? FF. If I go 256, it is 100. Okay, so look at this. This is 256. See, 84. See, this 8421, right? And then what is this? 16, 32, 64, 128. So we can represent only using last octet how many? 255. Since it is 256, you see, we got the 1 here, right? It makes sense, isn't it? Okay. So now let's go. As I increase, what is getting increased? 0.0.0. What is 1? 1.19. Okay. So it doesn't change. Likewise, in decimal, we have after 10, 11, 12, 13, 14, 15, 16, and so on, 19. After that, we get a 20. So, as I actually, instead of hitting up arrow, which takes quite a while, so let me go 5, 10. Okay. So, I'm reaching the last octet, end of the octet, you see. If I hit, see, 256 plus 256, how much? 512. Okay. See, 511 is 1.255. If I go to 512, what is the next IP after 1.255? 2.0. Right? Okay, you can see the difference here also in a hexadecimal notation. After 1FF, what is next IP? 200. Okay, so let me enter some random IP. Okay, so 192.168.5.11. Okay, this is random. So if I increase this one to, okay, on 68.1.15. Okay, that's kind of bug it is there, right? Yeah. Okay, so as we go here, 172, and what is next IP after 255 here? 192.168. Yes, 2.0. Got it? Okay. That is how it is. Just a pure number, okay? Counting from 1 to 4 billion. But we are representing in a dotted decimal. So, do you understand different notations? What are different notations of IP addresses? Binary notation, hexadecimal notation, or hexadecimal notation with the subscript, or dotted decimal notation, which is a base 256, which is quite popular, and that is what we use everywhere. And since it is hard to communicate with this, hard to actually communicate with binary notation or decimal equivalent of a decimal number. What we use a dotted decimal, which is somewhat actually easy to remember. Of course, we can't remember all IP addresses. That is where we use DNS, domain name system. Okay, So do you have any questions in this binary IPv4 address, which is 32-bit string, 32-bit number, a 32-bit string, binary string? So where we use 32 bits to represent this number. It ranges from 0 to 4.29 billion. Okay, and what is the last IP here? Last IP is a 255.255.255.255. As you can see, this is the last one, last IP here. Okay, so what is the last IP? FFF. See, all are ones. Okay, so as a change here, which octet is getting changed? The first octet, right? Okay, and so how do you convert between different notations? See, if I have a 192.168.2.12, it is easy to write. You can directly convert this whole number as a binary. You will get this one. Okay, if you convert this one to the binary, what you will get? You will get this one. Okay, this is decimal value. Convert that to the binary, you will get this one. Another way is you have dotted decimal. Convert each octet to binary, you will get this one. And this is quite easy because what you see, it is 12. 8421, this is 12, right? Yeah, you see, this is 2. This is 2, isn't it? Yeah. Okay. So, okay, we have seen the other day. Okay. See, this is the value. Let me convert that to the binary. Okay. Bin, you can enter that one. You see, that is the same. I can copy this thing. If I remove spaces here, okay, same value. But see, it is same, right? But it is quite hard. You need to do a lot of calculation, divide by 2 to get this value. The easiest way to, if you want to binary, is the easiest way to convert this value to binary is actually get the dotted decimal and then convert that to the binary by writing each octet as a binary. Okay, binary value. As you can see here, see, it is 168 is the same, right? 168, 128 plus 32 plus 8, which is 168. Okay, so how do you convert this value to binary? This value to doctor, let's say, just in case you have this IP address given, if you wanted to convert that to dotted decimal, how can you convert? How to convert? See, let's say that you have decimal value given. This value, got this one, this value. How to convert that to the dotted decimal? Which is simple. We land, we do that the same way we do any base to decimal. Sorry, when we convert from decimal to, if you want to convert to any number system, what do? What do we do? Hello? See, let's do, we divide that by 256. What is the IP address we have there? Which is, yeah, 192 dot, yeah, 168 dot 2 dot 14. Okay, this is the one here. So this is the decimal value, which is 3 2 322 36046, right? Okay. How to convert this one to dotted decimal? We divide this by C. For your understanding, let me ask you a simple question. Just a moment. It's not, my pad is not working. Yeah, we're good to go. Okay. Let me give you a simple question. If you have a decimal 14, how do you convert to the binary? 2, right? 2. Okay. So so that way, if you want to convert this number to dotted decimal, we divide it by 256 because dotted decimal is base 256. As you can see, if you write a 8421, so what is the 14 value? 8 plus 2 plus 1, right? Same, right? So what is remainder here? 0. 2, 2 threes are 6, right? Yeah, 2 ones are 2, remainder 1. As you can see, if we write from bottom to top, so what you will get here, 1.1.1.0. Okay. So yeah. Okay, now we need to divide it. This is what quite difficult. Let's take a help of the calculator here because that is quite big number. Okay. Okay. In Python, we can give, there's a IP address library available, so we can give the, okay, that was some string error. Okay. Yeah. This is the number, right? Uh, yeah, decimal IP equal to this one. How many times this number actually, if you divide by 256, okay? 256. What is the remainder? This one is the remainder. Okay. Sorry, coefficient, not remainder. So this is the value, right? So when you divide by when you divide, uh, what do we get is here is a coefficient. Okay, so what is left over is the remainder is 14. Okay, so which is a 1 2, just a moment. Okay, so let's write that thing. Coefficient is 1265922, right? What is the remainder? 14. If you divide this thing by 256 again, okay, what is this? How much we got here? 49320. Okay, which is coefficient. What is the remainder? 2. 256, which is a 49320. Remainder is 2, and again divide by 256. Okay, what you will get now? Are you there with me? Hello? As you can see here, resulting value is 192, which is 192 and 168 is a reminder. So as you write what you will get, 192 dot 168 dot 2 dot 40. Okay, so this is a dotted decimal representation of this very big decimal number. And so as you can see here, that is what we have here. This number converted to dotted decimal. As we divide, if you want to convert any IP in the form of decimal value, if you want to convert that to the dotted decimal, what do? We divide that number by 256, and we write the weeks. We store these reminders in each division, and we write them from in reverse order. And what do we get? We will get IP address in dotted decimal notation. Why we are dividing that by 256? Because dotted decimal notation is base 256 number system, which contains 0 to 255 literals. Since we can't find 255 different symbols, so we just simply use numbers from 0 to 255 from decimal as a simply some symbols. And this is the IP address phrase from representing from 0 to 4 billion addresses. And different notations are very popular. Dotted decimal notation, where each octet, which contains 8 bits, is written as a decimal equivalent value, and we get the And as we write each octet into decimal equivalent and we get the 4 octet, so we call it as octet because 8 bits are used to represent one decimal equivalent value from 0 to 255. So we call that as an octet. Octa means 8. And so representing each octet represents 0 to 255. Total we have 4 octets. As we divide the 32 bits into 8 bits, we get the 4 octets. And that is dotted decimal. This is hexadecimal notation, or simply representing decimal value into hexadecimal number system. And that is about the IPv4 address.